Hello people! Today we're looking at reaction of alcohol. So far we looked at the reaction of alkane, we looked at the reaction of alkene-alkyne, we looked at the reaction of benzene. So let's go over those functional groups and look at the reaction of alcohol. Now, before we look at how alcohol reacts, let's talk about how to prepare alcohol, how to make an alcohol. Okay. So number one, this is the one that you do know of already. So if you take an alkene and you add it to water, of course we remember following with Markovnikov rule, under acidic condition, you will get an alcohol. But I'm going to be specific here. Okay, I'm going to be very specific here. Other than ethene, that you'll get a primary alcohol, everything else you will actually get a secondary alcohol. Now this is what I mean by that. So I have here ethene. Okay, if I react this with water under acidic condition, we know that water will break apart to H plus and OH minus, and this double bond will break. And I guess one participant will get the H and the other participant will get the OH. Like that. However, if this is a more complicated alcohol or just a longer, a more complicated alkene or just a longer alkene, you have to apply Markovnikov rule. Now, if you remember a Markovnikov rule, rich gets richer, you'll end up with this alcohol, which is a secondary alcohol. Okay. Now, what if you're really adamant about this and says, I want a primary alcohol I want a 3-carbon. I don't want isopropanol. Okay, I don't want 2 propanol. I want 1 propanol. How am I going to do that? How am I going to make 1 propanol? Now, I'm not sure if you've ever thought about that, because if you think about alkene reacting with water to give you the alcohol, you're always going to get a secondary alcohol. All right? You're always going to get a secondary alcohol. The only way you can get a primary alcohol is through another reaction. Let's call this reaction 2. Okay? In this case, nope, you are not going to use an alkene. Okay, because alkene is not going to work. You're going to use an alkane. Okay, let me show you. Actually, you're going to use an alkyl halide. Let me just do an alkyl halide first. I want to save the next one for something a little bit more complicated. So if you take an alkyl halide and you react that with water, what you're going to get, okay, is an alcohol. Simple enough, right? Now, let's take a look at some examples that I have for you here. They're pretty simple example. Like, for example, CH3, CH2, CH2, Cl. That's an alkyl halide. That's 1-chloropropane. Now, if you react this with water, okay, you will also get an alcohol. What happened here is this. Let's draw H2O. Okay, that HCl is going to be made. Okay, so one of the product is HCl plus this OH will come over here hooked up with that carbon. So you have CH3, CH2, CH2, Cl. There you go. That's how you make a primary alcohol. Okay. So if you want to make a secondary alcohol, most likely you want to start with an alkene. If you want to make a primary alcohol, you might want to start with the alkyl halide. And here's the question that I want you guys to do. Okay, I want you to think about this. This is called reaction pathway. Okay, have you heard of reaction pathway? No, glycolysis was a reaction pathway, right? So this is called reaction pathway. It's not a big pathway, but it's good enough. This is what I want you to do. Okay, I want you to do this example right here. I want you to prepare butanol, 1-butanol, using butane. Okay, how are you going to prepare this pathway for me? Well, so pause this video, okay, figure it out, and unpause. Now the hint here is look back in my previous lessons on alkane. So pause. All right, after you unpause this video, obviously I'm gonna tell you the answer here. I'm not gonna keep you guys guessing for long. So you start with butane. Here's butane. Okay, I'm not gonna draw the hydrogen. Maybe I'll draw the hydrogen just for you guys. Here's butane. I want to turn butane into butanol. How am I gonna do that? Okay, first of all, to make a primary alcohol, you need an alkyl halide. The question here is, do you know how to turn an alkane to an alkyl halide? Okay. It does sound like something that we've done before, isn't it? And we have, actually. We have done something like this. And let's take a look. We can react alkane with an halogen. A halogen like Cl2. It doesn't matter. You can use I2, F2, Br2. It doesn't matter. And under the influence of UV and heat, we've seen before, you're going to get this. Now, the thing is this, though. You're not just going to get this. Okay? From the lesson we learned on alkane, you're going to get other chloropropane. You're going to get like 2-chloropropane. Sorry, chlorobutane. Okay, you're going to get 1-chloroputane. You can get 2-chloroputane. Okay, but what you're interested in here is your 1-chloroputane, which means the other butane does exist, but you're going to somehow use your laboratory skills to isolate this one. And it's usually very simple because remember, different compounds have different boiling point. So if you were to do this reaction, okay, and in your reaction vessel, you're gonna be left with a mixture of this and probably this. All you have to do is maybe boil. Okay, boil the solution. One of them is going to evaporate before the other, and then distill the other one. Okay, or the one of desire. It depends on who has a lower boiling point. So let's say we are only interested in this one, we only know of this one, and then what we're going to do? Well, we're going to continue with this reaction. By continuing the pathway, we're going to react this with water. Okay? In a form of substitution, chlorine will pick up one of the H's, so the OH will be bonded to this carbon right there. So this is what you're going to get. So that's the pathway in terms of how to prepare a primary alcohol from an alkane. So the tricky part of organic chemistry, again, is that there's these pathway reaction that I might ask you, or IB will ask you, somebody will ask you in the future. Okay? You start with a starting substance, and this is your ending substance. What are you going to do? Okay. In fact, on your next test, there will be a collection of these type of questions. Okay? Because I believe that just giving you a single reaction of predicting the product to do is too simple. You guys can do it no problem. It only makes sense that if I give you a pathway reaction where you have to take a look at a few different types of reaction and put them all together. That's what we're here for, and I'm here to prepare you for that. So, hey, hopefully you got this. Okay. Hopefully you got this. So, those are the two preparation of alcohol. So now let's take a look at the reaction of alcohol. Just erase all of this. Nice. All right, let's take a look at the reaction part of alcohol. What will alcohol react with? And what are the products that you will see? Okay. So, reaction number 1, combustion. We've seen this before. Okay, where you're reacting, let's say an alcohol, like here, methanol, with oxygen gas. What you're going to get, of course, is carbon dioxide and water. Okay, so alcohol being combustible is not something that you don't already know. So let's move on to something that you don't know. And this reaction is called elimination. All right. This is sort of like the reverse reaction of what we've seen before, where we take an alcohol and under the influence of sulfuric acid, to be specific, you're going to get an alkene plus water. Okay? Yes, this is actually the reverse of hydration. It is. So let's take a look at this. So you have 2-propanol. Okay? What would you get from this? So let's draw 2-propanol. Here's 2-propanol. Okay, let me draw these H's. Okay. For elimination, we know for a fact that you're going to get alkene. So where are the alkene coming from? Well, this OH is going to grab some H's. It can grab this H to make water, like we see here. It can grab this H to make water. Okay? It can grab any H except for this one. That's pretty obvious. You would know why. You can't just grab that one because who are you going to double bond with? Double bond with yourself? That's gross. Okay? So, here it is. Let's say it's this or this. It really doesn't matter because of the symmetry of this molecule. Let's say you're doing it with a right hydrogen. And this is what you're left with. Okay, this will be a propene plus water. All right, so it's pretty simple. There's not a lot of reaction that deals with alcohol. Alcohol is, well, I wouldn't say it's, not reactive. It's actually very reactive. But we'll save it for the next class when we look at carbonyl. Okay, save the fun for later because there's something way more important that I need to tell you today. All right, let me give you another example. Okay, and then we'll move on to the third reaction, which is my favorite reaction of all time because it smells. All right, let's do this one. I know, I'm like drawing this all over the place. All right. How about you guys pause and see if you can figure this one out. All right. After unpausing, this is not as easy as it looks. Okay, there's a reason why I did condensed formula, because it's just to make things a little bit more difficult to see. Because if I were to do structural formula, you would say, hey, I get this. This is not that hard to see, but it's really here to trick you. All right. You may be thinking, all right, I can form water right there. So the double bonds between these two. Okay, I can form water right here. So the double bond would be between these two. Will this and this be the same? No. We know it's different. Okay? Do it, name it, and you'll know they come up with different names. But is that it? Actually not. Because hopefully you guys got this one as well. There's H2O. It can form double bond with that. Okay. So in this case, yes, it's a snake question. You end up with 3 different types of product. You have this. You may have this. Or you might have something cool like this. Plus water. Okay? All 3 of these have different names, and they all are capable of forming. Remember, if you're interested in this one, you can easily look up which one has a lower boiling point, and you will just distillate it. Okay? Alright, so hopefully you guys get the idea of elimination. It's really just the opposite of hydration of alkene we saw yesterday. But with this, there's other tricks that you may want to, keep in mind. All right, let's clear this page, because we have something very important, which is the third reaction. The third reaction is the most important reaction. It is the reaction that is widely done in the chemical industry. Okay, it's called condensation. You've done this before. You've done this in biology before. Okay? You might not call it condensation. You might have called it dehydration synthesis, because that's exactly what it is. You're going to create water, and you're going to put 2 things together. What do I mean by that? If you take an alcohol and you react it with another alcohol, okay, under an acidic condition, you will get something called an ether plus water. Okay, do you see the dehydration synthesis here? The dehydration, of course, is that you have water being one of the product. Synthesis, of course, is putting 2 things together to become one, and that would be the ether. So we're going to go back and do a little bit of ether nomenclature today, and just figure out how to name these guys. But before that, let's learn how to put together ethers. So I have right here methanol. Okay, and I'm going to react this with my favorite alcohol, ethanol. Notice I drew it backwards. Well, not really backwards. I drew it in a way where the 2 OHs are facing each other. Okay, reaction will not occur if the compound is not on the right orientation, and you already know that. Remember when we were talking about kinetics? We talked about that. In order for 2 things to come together and react, the correct orientation must occur. And the orientation here is that the 2 OH must face each other. All right, why do they have to face each other? It's because one of the participants will donate OH and the other participant will donate an H. Like that. Okay, so let's draw this in actually. Let's draw this in. Here we go. Okay, this OH come together with this H. Okay, they will form water. just as we expected. Now, because of that, this carbon right here is missing a bond. This oxygen right here is missing a bond. What do? Well, of course, bond with each other. Okay? This is the synthesis part. So what you have here is CH3, O, CH2, CH3. Okay? This right here. Oh, my goodness. This right here is what we call an ether linkage. Okay, and it's actually specifically pointing, of course, the COC configuration. So that's an ether linkage. Now you've seen an ether linkage. I'm sure you've seen an ether linkage. Let me give you a biology example, and hopefully I don't embarrass myself. Let's draw glucose. I think this is glucose. Mind you, I'm doing this by memory. Let's draw another glucose. Okay, both of these are specifically known as alpha glucose. Here you go. Now, you can make an ether out of this, certainly. If you think about the functional group that exists in a single molecule of glucose, you'll notice this is an alcohol. It is. I call it an ether alcohol. Why do I call it an ether alcohol? Because one molecule of alpha glucose, so just glucose, has alcohol functional group in it. It has an ether group functional group in it. Let me just show you. The alcohol group is pretty obvious. No, these are all alcohol functional groups. So there's 5 of these. And you may be thinking, well, where's the ether? I don't see ether. I see ether. Let me just put the carbons here. These are carbon, right? Look, COC. Just like what we said right here, COC. Whenever you have COC, that's an ether link. So a molecule of glucose is, a 5 alcohol derivative plus an ether linkage derivative. Now that's not what I want to get to. What I want to get to is I want to illustrate condensation using 2 glucoses. And this is something that you might have seen, hopefully. You might not remember, but here it is. There's your water. Okay? And because of that, this carbon is now missing a bond. This oxygen is mixing a bond. So there's Y's, of course, if you link the 2 together to make something ridiculous like this. I just want to know, do you guys have to draw this in bio? Because back when I was a student, we have to draw this from memory all the time. What a pain in the butt. There you go. This is what you're gonna get. Okay? There's a name for this guy. It's actually called maltose. Okay? If you look at the function of maltose, you'll know I love this stuff. Sometimes. Maybe all the time. Anyway, there you go. Condensation reaction in the form of, a sense of biology. So let me just give you one more before we move on to the nomenclature of these things. Okay, so I have right here propanol reacting with isopropanol. So under the influence of of acidic condition, what am I gonna get? So again, pause this video and see if you guys can figure this one out. Okay, after unpausing, let's figure this out. So I have here this, okay, and we know for a fact that this OH and this H will come together to form water. Now somebody might have asked, like, does it have to be this OH and this H? Can it be this OH and this H? The answer is yes, absolutely. Okay, which one is which? Well, it's all random. Okay. There you go. Okay. Hopefully that's what you got. Now is the fun part. How do we name ether? Now there's two ways of naming ether. There's a common method. Okay, and there's the Iupac method. So let's go back to this guy. How are we going to name this molecule right here? Now, let's go with the common naming. Okay? In a common naming, it is very simple. Very simple. You look at what's on the left of the O and you look at what's on the right of the O and you determine what they're made out of. Okay? So, to name this, we have a methyl group on the left side. And on the right side, we have an ethyl group. Put that into alphabetical order. This guy is called ethyl space, no comma, no dash, space, methyl ether. Okay, ethyl methyl ether. How about this one? Okay, we have a propyl. We have an isopropyl. So, propyl. Okay, isopropyl ether. Very simple. Now, this way is no longer useful because let's say if I have many other things. So there's other functional group involved. And this is not going to be a fun way to name using this naming method. You're going to have a whole bunch of things all over the place. So instead, there's an Iupac naming method that goes with this. And let me just show you exactly how this works. Okay. How this works is this. In terms of this molecule right here, okay, you want to find who's the longest chain. Not involving the O, not involving this guy. Okay, this will be the longest chain. I guess you would agree. So the longest chain here is based on an ethane. This whole thing is one side group. Okay, so let me just mention this again. You look for your longest carbon-carbon chain. This is your longest carbon-carbon chain. This whole thing is a side group of this long carbon-carbon chain. So what that means is that your name will be ethane. This is an ethane. Okay? If this is just acting as a side group, you would say this is going to be carbon number 1 and this is going to be carbon number 2 because that's the only side group that you see. This right here is called methoxy. So this is called 1-methoxyethane. Now, you don't really need to put the 1 because it's ethane. Methoxy can only be in the number 1 position. So some people just call it methoxyethane. See? Okay. So something that you will need to know, we're going to do a few examples with ether. So therefore you're good at naming ethers. And let's take a look at this one. This one is a little, I guess, troublesome because the longest chain. this is the longest chain. This also can be the longest chain. They're both 3 carbons long. So which one is a side group? Now the answer is it doesn't matter. This guy will have 2 names and both names will be marked correct. Let's say this is the longest chain for now. Okay, this is the longest chain. And this will be carbon 1, 2, 3. And this will be a side group. As a side group, this guy is called 1. Okay, isopropoxy. Okay, isoproposy, whatever. Propane. Okay, which means if you were to say this is my longest chain, this is my side group, well, what are you going to do? Pretty simple. If this is your longest chain, again, this is also a propane, no big deal. We know it's a propane. Okay, and the numbering right here is 1, 2, 3. So at number 2 position, you have this side group. And this side group is a propoxy side group. Okay, and it's at position number 2. So this name, this guy right here, will have 2 Iupac name, and both of these names are okay. You'll find both in any organic literature. Okay, so I guess it will have 3 names. Some people have many names. Okay, like me. Any questions about all of this? Just don't be afraid to comment. Okay, on the comment section, drop me an email and ask me. So let's continue. Okay, let's do a little bit more. Oh, I don't know why I just did that. That was bad. All right, let's clear this up. And let's take a look at some ether nomenclature. Now, ether in terms of priority chart is way at the bottom. Okay, as you can see, we've been naming things on an alkane basis, so it's lower than alkanes. Ether is just a side group. So I'm going to look at some complicated ether now. Well, let's start with this one. The simplest ether. Okay, so in terms of common name, most people call it dimethyl ether. The reason is very simple. You look at the left side of the O and the right side of the O, they're both methyl. So you wouldn't say methyl ether, so people say dimethyl ether. Okay, so you'll have, diethyl ether. Okay, dipropyl ether. And we saw earlier that if they're different, you name them alphabetically. But what happens when they get too complicated? Like this. What do you do then? Okay, are you going to name this guy as, I don't know, 2-chloro-2-methylpropane ethyl ether? Now that will really confuse readers. So what they do is exactly what we do with Iupac. You find whoever has the longer carbon-carbon chain. Okay, it looks like this guy is a longer carbon-carbon chain, which makes this whole thing a side group. This whole thing a side group. Okay, and because of ether being not very important, it is relatively the same as an alkyl. So you will treat ether and alkyl the same way. You make sure if they are together in one molecule, you want the lowest number, because importance is not important. You know what I mean. All right, so here it is. This is your longest carbon-carbon chain, right? So you're going to go from right to left. Okay, because there's something at number 1 and you want to note that. Okay, if you go from left to right, this will be number 3. This will be number 3, and this will be number 2. So you have 2, 3. As I said, these are equivalent in terms of priority, so therefore you rather have 1, 2. Remember that. What? All right, let's name this. So we have 2-chloro. Okay, 1. Now, what do you call this? Well, alphabetical order-wise, you look for the E, because this is an ethoxy. So therefore, it is the E that you use for alphabetical comparison. So you'll have ethyl, maybe later on, and ethoxy. Well, ethyl will come, ethoxy will come first. Sorry. Okay, so that's 2-chloro, 1-ethoxy, 2-methyl, okay, propane. So, oh, there's an O here. So the 2-chloro, you're looking at this guy. 1-ethoxy, you're looking at this whole thing. 2-methyl, right here, of course, propane is based on the 3-carbon chain molecule. All right, let's do another one. And I'm going to ditch these H's. All right, let's move on to something big. Carboxylic acid, ketone. Oh, ether here, ether there. Ether everywhere. How about bromine? Yeah, you like that? And yeah, that's it. I'm just trying to illustrate ether here and not try to kill you on everything else. So here it is. Okay, be glad this is a carboxylic acid, because we know that this guy is always going to be number 1. So here it goes. This is a 9-carbon chain. Let's try not to make so many mistakes. So you have number 8, bromo. Okay. And number 4, I'm trying to do this carefully. I'm taking a look at this guy right here with an O. So that's an ether. So we call this an ethoxy. Okay. Number 3, I see, oh, hiding over there, is a keto. Okay. We took care of all the functional groups except for these 2. Okay, these are methoxy, and there's 2 of them. So, just like what we've been doing before, at position number 6 and at position number 7, you have a dimethoxy. Okay? Dimethoxy. Non-anoic acid. Okay. I hope you're comfortable. I mean, it's really not that hard, but it's just another thing to name, that's all. Alright. I guess I'll give you one to finish off the day. Let's take a look at this, and you guys do it for the day, and we'll call it it. I'm sure you guys are tired. All right, here it is. Looking great. Yeah, I was going to put something more, but I'm sure you guys get the hint. So why don't you guys name this one? Okay, and that will bring us to the end of reaction of alcohol and the nomenclature of ether. Next week, we will look at reaction of carbonyl. Yeah, hopefully we can handle that too. All right, have a good weekend, guys. Bye.